All right, I'm going to do special right triangles. We've done special right triangles in geometry. You had your 30, 60, 90 right triangle. And if you remember the rules for this we call x, this we call x square roots of 3, and this we call 2x. So when you're dealing with these triangles right here, you have a comparison between the three sides of x, x square root of 3, and 2x. So that's what you're looking at when you're doing these guys. And if you think about it in terms of Pythagorean theorem, you would have x squared plus x square root of 3 squared equals 2 squared, because a squared plus b squared equals c squared. So what happens here is this becomes x, this becomes 3x, squared, and this is going to become 4x squared. So it does work out in the Pythagorean theorem, which is actually how somebody derived this rule in the first place. The other thing that you should notice here is that the side opposite the smallest angle is the smallest side. The side opposite the largest angle is the largest side. And then the middle one, of course, is the middle side. So your sides are going to correspond size-wise to the angles that they have, okay? The only thing that we're going to change here is that instead of being in degrees, we're going to make it in terms of radians. So you guys remember I told you guys 90 degrees is pi over 2. So this is going to be pi over 3. And this is going to be 2 pi over 3. No, that's not right. I'm sorry. This is going to be pi over 3. I apologize, guys. This is going to be pi over 3, and this is going to be pi over 6. My apologies. Okay, so when we're talking about these, we're going to talk about them as special right triangles. And when we say that it's a special right triangle, this is one of the special right triangles that we're going to refer to. But we're not going to refer to them as 30, 60, 90 because we're really looking at pi over 6, pi over 3, and pi over 2 as our angles, okay? But our correspondence is still the same. So the angle that's across from the pi over 6 is going to be x. The angle that's across from the pi over 3 is going to be the x square root of 3. And the side that's across from the pi over 2 is going to be the 2x. So let me solve some really fast. So it gives me something like, it says, hey, this is a special right triangle. This is pi over 6. This side is 14. Find all the other sides. Well, the side that's opposite the pi over 6 is x. The side that's opposite the pi over 2 is 2 times that. So this is going to be 28. And the side that's opposite the pi over 3 is going to be x square roots of 3. Now the only thing that really changes here is when I have something that tells me this side is 14. So now I say, okay, well my x square root of 3 equals 14. So that means x equals 14 over the square root of 3. Because I would divide by that to get the x by itself. But I'm not supposed to have a radical on the denominator of a fraction, so I have to rationalize it. The way I rationalize it is by multiplying by the square root of 3. And since this is an expression, I can only multiply by a variation of 1, so I have to do the same thing to the top and the bottom. So I get 14 square roots of 3 over 3. So that's my x value. So this side over here is 14 square roots of 3 over 3. And if I could simplify that, I would. And this side over here is 2 times as big as that, so it's 28 square roots of 3 over 3. So that's what we're doing with those guys. The other one that you guys should remember is the 45, 45, 90 right triangle. And when you guys had this, you had x, x. These are the same angles, so they should be the same side length. And this is the x square root of 2. So again, doing the Pythagorean theorem, I would get x squared plus x squared from a squared and b squared equals x square root of 2 squared from c squared, which gives me x squared plus x squared equals 2x squared. So it does work out, which is how somebody derived that in the first place, but just to show you. So the difference here is this is going to be pi over 4, and this is going to be pi over 4, and this is going to be pi over 2. So now our pi over 4s correspond to x, and our pi over 2 corresponds to x square root of 2. And that's really all that we're going to deal with today. Now I told you I wanted you to do some problems on here, so here are the problems that I want you to do. Number 1, find all the sides. This is a, well, hopefully I can draw it big enough. This is pi over 6. This side is 3. Find all of the sides. Number 2, this is pi over 3. This is 3. Find all of the sides. Number 3, this is pi over 4. This is 6. Find all of the sides. So it shouldn't be too hard for you. Bring those two with you to class.